Hi, I'm Hadi from Ceyear Instrument. Today, I want to show you our Terahertz test solution for signal generator and spectrum analyzer. The top is Terahertz parameter, the bottom is microwave signal generator. We use signal source frequency extender module, the left one, to expand the frequency to 117 GHz. And we use the spectrum extender to down-convert the high-frequency input to a normal spectrum analyzer to further characterize the terahertz signal. We can use terahertz power meter to test the output power at different frequencies. Let's calibrate the power sensor before testing. We connect the terahertz power sensor's type N connector to the calibration source. We press Care button and select Calibration soft key to start the calibration process. OK, it's done. I put the signal source extender module on the power meter and connect the power sensor to the module. We set the generator's frequency multiplier to 12, so the displayed frequency can be set to 110 to 117 GHz directly. We set the output power of the generator to 5 dBm and make the extender work in mature output. We set the frequency of the power meter and the generator to 117 GHz, and we can see the output power is about 6 dBm. We change the generator's and power meter's frequency to 150 GHz, and we can see the output power is about 9.5 dBm. We change the generators and power meter's frequency to 120 GHz. We can see the output power is stable at 8.9 dBm. We change the signal generator's frequency to 110 GHz. And we also need to change the parameter's frequency to 110 GHz. You can see we can get a stable output at 8.1 dBm. Ceyear can provide signal extender modules from 50 GHz up to 750 GHz. Please contact us for a live demo if you want. Now, we use terahertz spectrum analyzer to capture the signal. Because the output power is relatively high, so we insert a terahertz coupler between the extender modules. The degree of coupling at 120 GHz is about 50.3 dB. This is Ceyear high-performance spectrum analyzer. The instrument itself can cover up to 67 GHz, but it can work with extender modules to cover up to 750 GHz. We use two RF cables to connect the IF and LO signal to the extender modules. The purple USB cable can help to detect the extender automatically, and the signal identification function can help only display the real spectrum line. We set the frequency center to 120 GHz, the frequency span to 2 GHz. We can see the peak marker is 120 GHz and the power is minus 7 dBm. We set the frequency span to 10 GHz and we can see the peak mark is at the same place. We change the frequency span to 200 MHz. We can see the displayed output power at 120 GHz is about minus 7 dBm. Considering the coupling degree, the measured output power is very similar with the power meter. That's all. Thanks for watching.